peeled off about 130 thousandths off from it, trued up the outside edge, and it's running pretty true. I see a little bit of a needle wiggle there, but good enough, I think. So over to the mill now, and we'll have to lay out those holes and drill the holes. All right, the part's out of the lathe and over here on the bench, and I think what I'm going to use to find the centers of these holes is our old trusty center finders again. I think I'm going to chuck them up in the mill to help me hold them nice and vertical, and then just use the pressure of the mill to make our dimples in the aluminum. Two different sizes, one for the threaded holes and then one for the non-threaded holes. We're going to oversize these holes anyways, slightly, as this QD coupling gets drawn down into that taper and it squeezes on the output shaft of the motor. These holes are going to change position a little bit. Those bolts are going to need to have a little bit of wiggle room in there, so we're going to upsize them slightly. All right, we're chucked up here in the mill, and I'm just going to use, like I said, the mill to keep us vertical, and just put a little bit of pressure on there to make our dimple hopefully right dead center in the hole. All right, we'll do the same with the larger center finder, and then we'll try to rig this thing up on the turntable again to drill those holes. Okay, this is unscripted and I don't always get it right the first time, but I'm back over here on the lathe. I've decided not to drill these holes on the mill yet because the holes have got to go all the way through this piece and into this piece once we mate these two together. So it doesn't make any sense to drill these holes yet. What I'm going to do now is I'm going to trim this down pretty close to this black line. Again, not a critical dimension. We're just shaving weight. I've already dial indicated this and got it back to within about a 1/2 thousandths of an inch. So it's dialed into the lathe to this 4-jaw, and now we can just whittle away at it until we get down to pretty close to the black line there, and then we'll be able to swap the thing around and work on the other end. All right, we got the piece turned around in the 4-jaw, and you can see the jaw's been making some pretty good indentations in this stock, and we weren't really that concerned about it before because we're going to turn this back down. But now that we've got it flipped around in the finished outside here, or it's pretty close to finished, I went ahead and put some soft jaws in there, which is really just some pieces of copper pipe that I've cut and flattened out and sandwiched those between the jaws and the aluminum, which then protects the aluminum. I've got it dialed in. It's pretty darn close. It's a little bit of a, needle bump around a little bit just because of those jaw marks in it, but as you can see, it's running pretty true, maybe a 1/2 thousandths. It might be a thousandths of an inch. If you go real slow, it's pretty darn close. That's close enough for our work. So I'll go ahead and true this up, or actually start turning it down, and we get down to really close to where the other side of it is. We're going to have to stop and take some more measurements and figure out what kind of diameter we want and the length of it, that shoulder that's going to step into the other piece. I know I'm not explaining that very well, but it's clear in my mind, so it'll become clearer in your mind as we work through it. I had another thought here. This thing should be centered up in reference to this center hole. That's what's going to keep it true. So I've set up a different dial indicator here, one with a ball on the end of it, and it's got a pivot point, and it registers, or it runs on the inside of that hole. And I had to work the jaws some more, take out it was showing about 6 or 7 thousandths run out on it, and now it's down to about, well, the inside of that hole is not perfectly smooth, but it's pretty darn close right there. So I think that's the way we're going to go with it for now. Alright, well, we have this piece turned down to 2 inches, and I think what we'll do now is we'll chuck it up back in the lathe on this end of the piece. Just knock this flange off is all we're going to do, just trim this flange off. We'll chuck this piece up in the lathe, and we'll open up this hole to just shy of 2 inches. Once we get it opened up, take it back out of the lathe, we'll warm this piece up, chill this piece, and then press the two of them together. And then they'll be pretty much one piece. We'll back that up with these holes. As we drill these holes, they'll go all the way through both pieces and really hold it nice and tight. Okay, we're set back up on the lathe with our flange piece. I had to go back to the 4-jaw chuck and reverse the jaws so we could capture it from the outside. I got the soft jaws in there as well, and I've dialed it in, and hey, how about this for a rookie? I think that's probably close enough, huh? Well, now we're going to bore this hole out, and we'll go up, we'll just drill it out with an 1.1 my biggest drill bit, and then use the boring bar and bore it on out till we get 2 inches or just shy of 2 inches. And we're going to have to be very careful as we work our way towards that final dimension, because we need an interference fit here, about 2 to 3 thousandths of an inch interference is what we're looking for. All right, miking this one more time, taking one last check of it to make sure that we bore that hole out to the proper size. Like I said earlier, it's a 1.999. That's pretty darn close to 2 inches. And we want to be just shy of that with that hole. So we'll take this, we'll zero this caliper out and use that for the nominal dimension. Start working the hole up bigger. As we get closer to the 2 inch mark, we're going to probably come back and forth. I'll probably use something a little more precise than this caliper, probably a micrometer and some inside hole gauges, and we're going to see if we can get this thing right on the mark. Alright, looks like we got about 820 thousandths to peel out of there. Hey folks, sorry I lost you there. I ran out of memory, didn't realize it. We've been working on opening up this hole. We're real close to our final dimension here. I've been using my carbide insert bit here. It's been doing a great job of just peeling the material out of there. We're real close to our final dimension. I'm going to take a couple of measurements with our telescoping gauge here and check it with our micrometer and make sure we're real close or real accurate. We want to be within about 3 to 4 thousandths under the dimension of this piece, so we'll have a press fit in here. So let me take a few dimensions. It's going to take both hands here, and I'll probably have to move the camera, but I'll be right back with you. I think we're going to be able to get this out with one final pass, and then we'll be ready to heat things up and squeeze them together. Meow. Alright, so 19 thousandths is what it's reading, and we're going to try to get about 15 thousandths off of that, so leave us about a 4 thousandths interference fit. That's what we're going to shoot for. So right now I'm going to peel off probably another 5 or 6 thousandths and take another reading and go from there. I have let this sit for a while so it's nice and cool, and we should be getting a better reading with it nice and cool. After I cut all that material out of there, it was pretty hot, which tends to kind of, you know, stretch things out a little bit. So important to let your piece cool down to get a real accurate reading. Alright, I think we're there. It's reading about 2 to 3 thousandths over. It looks like it's right there. I'm going to put a nice chamfer on this edge, not only to help us get it started, but also just in case there's a little bit. I mean, it looks like a pretty tight corner there in that corner, but just to relieve it a little bit. So let's chamfer it. I'm also probably going to take a facing run across this just to true things up here to make sure that we get a good seat when we press this in. All right, here's the setup. I have the press up here ready to go. The flange is in the oven. It's up to about 450 degrees, and the cup is in a bath of ice water. So I'm planning on bringing the flange over, heating it with the torch, bringing it up to around 550 or so, maybe 600 degrees, and then sliding the two of them underneath the press and squeezing them together. Well, I guess we didn't need the press. Hey, well, you know, you got lucky when it drops together like that. It couldn't have been any better. I think the plate was hotter than I thought it was. My thermometer, my digital Chinese infrared thermometer, was kind of all over the charts. Probably had plenty of heat on it. I did mic the hole, or put the calipers on it, you know, before I set it up in the press and got ready to drop the cup in, and it was showing that it opened up about 4 or 5 thousandths of an inch. So heating it does work, and as you could tell from the video, cup dropped right in, and it's in there. It's stuck. So it's not going anywhere, especially when we drill these holes all the way through and put the bolts through. That's definitely going to hold it together. So we're looking pretty good. The next step will be to drill these holes. We'll set it up in the mill, drill all 6 of these holes plus 2 more, which will help us remove the QD coupling if we need to. Let me get that set up and we'll press on from there. Hey, one little note here. You know when you found true love is when your wife comes out and cleans your lathe so you don't have to. All right, here's the setup on the mill. We've got 8 holes to drill here. We'll use the starter bit, of course, and work our way around the circle of 360 degrees and just pre-start all these holes. And then we'll come in. We actually got 2 different size holes to drill here. One for a 1/4 inch bolt and the other one for a 5/16 bolt. And we'll wind up pre-drilling all 6 of the holes with the 1/4 inch drill bit, and then we're going to open up 3 of those holes to a 21/64, so that's going to give us a little bit of play. You know, as we talked about before, that QD coupling needs to squeeze in, so we need a little bit of play on those 1/4 inch bolts. So we'll open that up to 21/64, so that'll give us about 35 thousandths on those 3 holes. And then the 5/16 holes we'll pre-drill with a 1/4 inch just to save some time from changing bits, and then we'll come back in with a 19/64 drill bit on those 3 holes. That's going to open up those holes about 45 thousandths and give us that room for that QD coupling to squeeze in. And then we're going to drill 2 more holes between 2 of these holes, which we'll drill with a number 7 drill bit, so we can run a 1/4 20 tap in there. That's going to help us push that QD coupling out from the backside. Once we draw that coupling in there, it gets pretty tight, and to push it back out, if we tap some holes in one of these holes, we can use the same bolts that we draw the coupling in with to then push the coupling back out. You'll see how that works if you're not following here in a little bit. But again, I'll probably just fast forward you through this. You can see the process, but hey, you've seen it enough. It's standard drilling from here. All right, I'm going to start with this number 7 drill bit. It's the smallest one, so I might as well drill all 8 holes with this number 7 and then step up from there. But when we finish with the number with this drill bit, this hole and this hole will be done. We won't, besides for chamfering them, we won't touch it again with the drill bit. So help me remember that so I don't run a bigger drill bit in there. All right, well, the number 7 drill bit run through all 8 holes. I've put these, just dropped some screws in these 2 holes to remind me not to drill those up anymore. The remaining 6 holes, we'll get this 1/4 inch drill bit. That's just to open up a little bit more. We still have the final 2 drill bits to go for the proper size. But most of the hard drilling is done. That initial drill takes a lot of work, a lot of stopping and cleaning the flutes out. But it takes out the majority of the material. So this ought to go pretty fast. Yeah, about 3.5 minutes to go around drill those 6 holes. A lot quicker than the first go around. All right, this is the final size for the 1/4 inch bolts. I dropped some temporary screws in these holes as well, just to remind me not to drill those holes. So those will be for the 5/16 bolts, and that'll be the last drill bit size, the 19/64. This is a 21/64 drill bit. Here we go. All right, we're all drilled, and the only thing we have left to do is a couple of taps. We're going to run the tap into those number 7 holes that we created to push the QD coupling off. And I'll run the tap in as far as I can. Again, I'll use the same method I use for tapping these holes. I'll get it started here with the mill, get it nice and straight, then I'll pull it out and hand tap it the rest of the way. Now there's no way we're going to be able to go all the way through this 2 5/8 worth of material. So we'll go the depth of the tap, and then I'll have to flip this thing back over and clearance drill from the other side down about, well, just deep enough to get past this starter thread here on the tap. That'll allow us to slide a bolt in from the other side, engage those threads, and then thread the bolt in until it starts pushing on the face of the QD coupling. I'll explain that a little bit later. Most of you guys probably got it figured out, but that's the plan, and here we go. Hey, we're almost done. Everything looks real good. The QD coupling fits real well. Our bolt holes are drilled, cleaned up, tapped, and ready to go on this end. We do have to do a little bit more work on the lathe. We're going to have to chuck it back up in the 4-jaw and center it, and then trim out some material, a little bit of a clearance for the bolt heads that'll fit in here. So we'll have to whittle it on down to give us enough clearance for all these bolt heads. These 2 holes here we won't have to worry about, although they'll get clearanced as well just because of the rest of them. But those are the holes that we made for pushing that QD coupling out. Let me see if I got a long enough bolt. Maybe, I guess I don't. But the idea on those, of course, was, we clearance drilled them there. The threads start, and if we had a long enough bolt, you would see that if you're trying to remove this QD coupling out of here after it's been tightened down and the taper is taken, and squeezed on down, it'll be pretty tight and be hard to remove. But all you would have to do would be to run a long enough bolt in there. It would start pushing on the face, on the back side of this or this flange, and then push that coupling. You do a couple of threads here, or a couple of twin turns here, and a couple of turns here, and eventually that would push that QD coupling off of there, out of that taper anyways. All right, so back over to the lathe, set the 4-jaw back up, and let's cut the clearance out of here. It just dawned on me that a lot of you folks may not know exactly what the difference is between a 3-jaw chuck and a 4-jaw chuck. The 3-jaw chuck is just like any other chuck that's on a drill press. Once you use the key to tighten it up, and when you do that, it it squeezes all three jaws in at the same time. It's got a scroll in the back and it squeezes them all in at the same time, which is great. It's nice and quick, but it's not as precise, or you can't really put eccentric parts in it. With the 4-jaw chuck, you're adjusting each jaw individually, and it takes a little bit more time to set up, but it gives you more options to chuck stuff up and to center stuff. You put this part in the 3-jaw, tighten it down, and whatever run out you have in that center hole is what you have. There's no way adjusting it. So the 4-jaw gives us the opportunity to move these jaws back and forth, and you get the run out very close, or next to nothing. So you can see I've got it set in the 4-jaw with the soft jaws in here so we don't damage the outside of it, and it's pushed up tight against the jaws. And I've got the dial indicator set to measure the run out on the inside hole there, which as we've turned this thing, we've always referenced that inside hole. So this thing should run pretty true. Now you can see that there's, well, let's see, there is, well, I just put that in the wrong position. Let's find the bottom there and zero out our dial indicator. So right now, we just roughly put in the 4-jaw, there's about 42 thousandths worth of run out in it. Now I'll do this off camera, because if you want to really know how this is done, go to one of the guys, A-Bomb79. He's a master at this. They actually have competitions on who can true up a 4-jaw the quickest. It takes me a little bit of time. Sometimes I move it the wrong way, you get the wrong results on the dial indicator, have to go back and undo it, or push it the other direction. So it takes me a while to do it, so I won't do it on camera. It just use up way too many zeros and ones. So let me get this thing squared away, and I'll bring you back in and show you the results, and then we'll get to turning. Alright, didn't take a whole lot of tweaking on it, but I got it within, it's about 1/1000ths out, but we're not turning anything with alignment. We're just going to make some clearance passes here for these bolt heads. So really it's all just for practice, or maybe even balance for this assembly. But we're pretty good shape. Let me get the tools set up and we'll get to cutting. All right, we should be ready to go here. I got a brazed in carbide bit in here. I'm going to try to just come in the center here and then ease back these corners. It gets pretty rough when you're not turning a solid piece, when you got segments like this. So I'm going to take it nice and easy and just try to ease these corners out. Once we get those out of the way, then we'll be able to come in here and we'll have to plunge in with a different bit and kind of plunge in and then cut back and forth. So let's get these corners out of the way. We're going to go up right up to the line here, just a real rough dimension. I used a Sharpie and the head of one of these bolts to kind of give us guidance on where we need to go. Alright, I didn't like the way that tool was cut. And remember, the only thing that's holding these two pieces together right now is the friction, or the shrink fit that we put in there by heating, cutting it undersize and heating and shrinking it together. So don't want to put a whole lot of tool pressure on here. Also don't want to get this thing real hot to have those two pieces come apart. I think they're solid, but hey, better to err on the side of caution. We got a high-speed steel bit in here. I just honed it a little bit, got it sharp, and let's see how it cuts. Alright, we got it all cleaned up. It's looking pretty good. I just made a high-speed steel bit to plunge in here and work back and forth and clean out the width of our screw or bolt heads. So this is a delicate process. It's going to kind of scrape the material out of there. It doesn't cut very well when you plunge in like that, but I'll take it nice and slow, working back and forth, and create that groove that we need for the bolt head clearance. cutting real good. Let me see if I can work on the end of that bit a little bit more and get it to cut a little better. Well, there it is. It's done. Everything seems to fit well. Bolts are in there. Those are not the proper bolts. I need some longer ones. I'll have to take some measurements and order some longer ones. Let's see. Let's put this line back on. It still fits nicely. We can bolt that on. Actually, the sequence of putting this thing together will be to put the PD coupling together first and get it all trued up on the output shaft of the motor, and then go ahead and bolt the splines on here, and then slide the engine or the motor and the transmission together. Pretty simple process. I don't know what this weighs. I could weigh it. I think it's going to be significantly lighter than a clutch assembly. I've had a couple of comments about clutches and whether to clutch or not to clutch, and hey, that's a decision that you have to make. I wrestled back and forth with it for quite some time. Saw a lot of videos, some people telling you to install a clutch, some people not, saying you don't need to. I decided not to. I can always back up, pull this thing back out, and I'd have to do this machining work over again. The adapter plate would be fine. I think I could install a clutch if I need to down the road. So I'm going to try it without. Hopefully it works fine, and I won't have any shifting problems. Maybe when this thing gets done, we'll do a video on how it drives and how it shifts without a clutch. So that's it for now. Episode 3. Hopefully I can squeeze this all into one episode. I found out with episode 2 that I had too much video and couldn't squeeze it all into one, so that's the reason why I had to break it up in part A and part B. Hopefully I'll get this one all in one video. We'll see how it goes in the editing. Once again, folks, I appreciate you watching, and I hope this helps. Appreciate the comments, and we'll talk to you soon. Coming up next will be, I'll do an episode on assembly. Oh my goodness! One last appearance from in this episode, anyways, from Jetson. We'll do a video on assembly, and then after assembly that'll probably be a short video. We'll start on the motor mount, and that's going to take some time. So once again, folks, thanks for watching. Get started on your projects. Hope to hear from you in your comments.